Hi, everyone. I definitely have too many slides to do in a minute, so I will be talking quickly. I'm going to mostly be there are a lot of different ways you can describe what it is we're thinking about. The one I'm trialing here is kind of this lead bullet solution idea to reducing AI risk. You may have come across the term guaranteed AI safety. This is an archive preprint that went up yesterday. A lot of interesting people all thinking that we should have AI systems that have an auditable world model, have the ability to, or users have the ability to create specifications of what safe means in that world model, and having a verifier that validates any proposal that comes out of an AI system using the model to validate whether or not the specification is met. And when I say world model here, you should think like world simulator rather than some kind of learned model necessarily. You should be able to use AI to accelerate and like reduce the computational load and increase the accuracy of the simulator, but think of it in terms of that. My first contribution to AI risk was this comment about lowering your standards for publication to Davidad. He proposed the open agency architecture, which became safeguarded AI, which is now one of these guaranteed safe protocols or architectures. When he talks about safeguarded AI, he draws something like this. And you can read all about it here. There's a great explainer video there, about 30 minutes long, that kind of, I think, motivates why this should be trustworthy for overarching safety. I take that picture and I draw this out of it. And I'm trying to not reinvent version control for scientific theories. I think that that's interesting, and I think it's compelling, and I think it should be done. But I don't think that it's going to solve a lot of the UX and risk, like AI risk problems that are showing up now with capabilities where we actually already have a model, we have a spec language, or we could very easily have a spec language. And so we should focus on something that's more user-focused, more short-term. And I think that we can actually reduce risk in the short term and maybe even improve risk-reducing capabilities. One of the additional interesting features is that a lot of the proxies I think people are or will be soon using for is this agentically scaffolded AI system out in the world doing well, is that people will use profit as proxy for good. And I think that this is deeply destabilizing. I also think it's interesting that a lot of plans for alignment kind of focus on an individual's preferences or like coherent extrapolated volition or things like that. But institutions and communities are not just an unstructured set of individuals. And in society generally, when we address these, we make laws about, we like set rules in each of these domains, and we have review processes, and those review processes scale for humans because the reviewers are human and the actors are human. But we could have systems where you have specification generation, and solution checking, where AI is assisting humans to do this review, and the review is kind of a thing you set up a priori, and then you have some amount of human on-the-loop review of AI that goes on when systems are deployed. I think that it is potentially easier to not wholly encode what you're trying to optimize for, just to make tools to set rules in specific domains where we have an ability to express what objective criteria for success or failure would look like, and then obtain proofs that the AI systems are obeying what you want them to be doing. My highly reductive infographic of this is like, currently you generate an informal spec, you get a solution from that, and then you have to approve this as a human. And we could have something that looks much more like this, where you have tools that help you at each step of the way do this effectively. Two areas that we're looking at specifically are if you want to take some legacy code base and like spec languages for software behavior exist. Formal specification is kind of the gold standard for cybersecurity. Allison mentioned SEL4. There are things like this which are very effective, very expensive. Can we have AI-enhanced specification generators and solution checkers to help make that pipeline work really well? I think this solves a UX and a customer acquisition problem for any safeguarded AI architecture. My hope would be to get large swaths of like critical cyber-physical infrastructure running formally verified code just to get people used to the idea that this is a direction that we can use to reduce risk from current human actors, but also future AI actors. I think you can also create new specification languages or things that act like new specification languages. I want to start this. I want to start a competition that looks like CASP, which was the competition that prompted the creation of AlphaFold. I want to do this for toxicity forecasting. I think that assembling the data set and creating the cultural Schelling point to just get people to focus on this could be the kind of thing that is sufficient to drive the scientific breakthroughs that are needed to be able to go from a small molecule to some objective measurements, and then that or some predictions of objective physical measurements that you could make to validate how much this interacts with various metabolic pathways, and then from those parameters evaluate LD50. This becomes something that is objective, easily specifiable, and it's a good way to encode subjective preferences that you might have. Whether or not something is harmful is going to be something that's very objective, but it would be really nice to have a specification generator where you could say, let me formalize what I mean by modify or harmful, and from that use a world simulator, basically the AlphaFold analog and the toxicity forecaster, and probably one or two other things to go from that to getting a system that can not just give you suggestions for things you should maybe make, but also have some quantitative checkable evidence that these things are not as risky as other systems might recommend. The goal is that this isn't just dialing down the toxicity number. This is actually getting checkable evidence that, or getting objective evidence that can be checked by non-learned systems effectively. The long-term goal would be to have this be something that we get a quorum of people agreeing that either researchers, frontier labs, all agreeing that safeguards like this are very useful for various types of outputs. And this is a link to those slides. Happy to take questions.
Thank you. Questions, comments? Well, maybe I will go with Michael.
Hi, Evan.
Hi, Michael.
In aircraft safety engineering, one of the main causes of air disasters is when the world model is wrong. This seems like a situation where it's actually much, much harder to construct a good world model, and you'd sort of expect more analogs of the crash.
I think I expect a lot more analogs of the crash in a system where we're not formally verifying the software on the planes. So there's the premise has a bit of survivorship bias, in that if we weren't formally verifying the aircraft, then you might expect a lot more crashes from the software. I do agree that there is a risk of gaps between the world model and risks in the real world. This is part of why I'm closely following and interested in, and the long-term success of this is tied to whether or not Davidad can actually create a version-controlled ontology for scientific theories. The idea would be that you should have a substrate where people can contribute as many or whatever insights they have to models that they would like to provide, and you have everyone working toward the best possible models. But there is always the fact that if there's a gap between the model and the world, that there will be a failure mode that's captured by one and not the other. I do think that if you're trying to reduce risk from adversarial proposals, that it's very likely that those gaps would exist in those gaps between the model, the understanding of the world and the world itself would also exist and be mirrored in the superintelligent system that you would probably have. And I think I think that tends to be something that agreement with that statement correlates highly with whether people's experiences in theory versus experiment, interestingly.
10 minutes, unfortunately. That's okay. We have more time to chat in the break. Thank you so much, Evan.